Welcome to this course of machine learning. I'm Tara Mehboob and I'm going to be your instructor for this course. My contact details are available and the teaching assistant for this course is Mr. Hassan Mushtaba, and his contact information is also present over here. He will help you navigate through this course. The textbook that we are going to follow is Machine Learning by Tom Mitchell, and the PDF version of this is freely available, and you can get that from Mr. Hassan Mushtaba. So as far as the prerequisites for this course are concerned, I've heard that you have studied the course of linear algebra. So it will help you understand the algorithms for machine learning. And of course, we need a MATLAB programming background. And if you have studied MATLAB, C++, or Python, that is a plus. If you have not already studied Python, no worries, we will help you during this course. The course contents that I'm going to cover are mentioned over here, and you will be assessed on basic 5 categories. First, I will introduce you to machine learning. Then we will discuss regression. What is the basic idea and what is logistic and linear regression? Then we will study the overfitting generalization and cross-validation. We will study neural networks, starting from the basics, multi-layer perceptron, and various techniques to optimize deep neural networks. Then we will study convolutional neural networks, recurrent neural networks, and after the mid, we are going to study clustering and naive Bayes algorithm, decision tree, cart, random forest, and support vector machines. There will be 2 quizzes. One will be before the mid and one after the mid. And these quizzes will be from within the lecture contents. We will have 3 assignments. 2 of them will be programming based. For one assignment, you will use ML software. And the other one, you will need to have some programming in MATLAB or Python. And for the first assignment, it will be a numerical based. So my main focus for you guys, for you people, is the project. So we will have a submission of a project at the end of the semester. The project will be divided into 2 modules. One will be submitted before the mid and one will be prior to your final. I encourage you to work hard for this project because we are going to have this an implementation based. You can take help from me and also from your TA as much as possible. We will have 2 exams, the midterm and the final term. They will be paper based. So you can take as much help from me and the TA. If you have any queries, any problems, you can freely contact us. You can discuss your assignments and your homeworks and your projects with your friends. The project will be an individual one, but you have to do it yourself. So if there is plagiarism or there are copies, it will not only be a 0, it will be a minus score. This is the lecture breakdown of weekly schedule. So if some of the points that have not been covered regarding machine learning algorithms that you want me to include, you can convey that to me and we can have a discussion, and then I can include that within the lecture contents. So what is machine learning? Machine learning is basically and improve. The target is to improve the performance of programs based on given data, previous results, and experiences, or a combination of these. So the goal of machine learning engineers and data scientists is to develop methods to extract knowledge from the existing examples. They have already developed some tools and methods for creating computer programs by use of analysis of the data sets. So what is the data set? If you're not familiar with this, I will go into the detail. First, you have your raw data or raw input. That is, for example, your video streaming history or your browsing history, for example, shopping browsing history. It is pre-processed by the engineers or data scientists to extract meaningful information, that is knowledge. And when they have the meaningful information, they use that and restructure your data. The restructured data forms the data set, which is then input into your machine learning algorithm. So the target of all this machine learning ideas and concepts is to find the patterns in your data. So as I told you, your video streaming history might have a pattern. It has a pattern. That pattern can be one day, that pattern can be 1 week, or that pattern could be 1 month. We could call one day a short-term pattern and 1 month a long-term pattern. So we need to extract the meaningful information from this. Or we could use patterns within the data set to solve problems. So what kind of problems can be solved? For example, if you are a user and you are accessing video streaming service, so you are actually accessing that from the edge server that is close to your access point. The edge server is then connected to the cloud or the internet. And then we have the content distribution network. So the data that is most popular among all these users, it is cached onto the edge servers. So you don't have to go through a long path up to the content distribution network, it's the data servers, to watch the video streaming, and it of course increases the resource usage. So some of the most popular contents can be cached at the edge server. So user will have access to these popular files directly from the edge server and not from the internet or from the CDN. So now we have, and the base is that we find the popular content. How can we do that? By using the patterns in the data. So the core of this is that you are using the patterns within the data to solve various problems. There are several applications of machine learning. You are most familiar with voice, face, fingerprint, DNA, signature recognition. Then we have web search, document and information retrieval, machine translation applications, and the recommendation systems and spam filters, for example, in your emails. And then we have the recommendations. I will go into a little bit detail for the recommendation. So you are a user and you have a video streaming history. So based on your watched contents or accessed contents, the Operators will not only cache the contents, they will also recommend you some videos. Some of the videos, they will be closely related to your previous history or the genres that you are interested in watching. But some of them, for example, they could be like, for example, this is a geographic area and you are the users. So within the geographic area, some content may be trending, or it could be geographic based. So that content can actually be recommended to you. For example, this was the previous, right now there was a season of FIFA World Cup. So the videos that are, or the short videos, they could have been recommended to you, although a month ago there were no such recommendations. So they can be time based also. And then you keep on watching these videos and then they become part of your browsing history. Then we have marketing, stock market predictions, credit card fraud detection, loan application. Here we have the risk management. For example, a client put forward a loan request. Either it will be approved or not, based on the historical information of user credit history. So that user, the banking system could use this information using an input into a machine learning algorithm, and then based on that information could propose giving the loan or not giving the loan. So using that information, the bank can actually or the financial institution can actually make a decision. Then we have we have some application in gaming, online gaming also. They heavily use deep learning, machine learning algorithms for optimized video streaming, graphics, and content delivery to the user. Then we have some related disciplines to machine learning. First is pattern recognition. So in pattern recognition,